issues with that, let me know. We're just waiting for others to join. Welcome to the sustainability series by Lancaster West. We'll just give it a few more minutes until others join, and then we'll make a start. Just checking to see our speakers are here.
Yeah, but I think they are.
Hi, Sean, I'm here. And my colleague who's talking is also here.
Oh, hi. Hi, Lizzie. Hi, Duncan.
Yeah, hi. Sorry, I'm here.
People coming in. I think we've got 39 at the moment, which is good. Who's this?
Hello,
Hi.
I'm Niall.
Hi, Niall. Right, should we make a start? My name is Sean Hayden. Thanks for joining us today. This is the first of our series of 12 sustainability series, almost kind of talks or seminars for colleagues on Lancaster West and beyond. We are basically going to use an hour every month to give colleagues a good press understanding of some very meaty topics on the sustainability agenda. We're hoping to have guest speakers at all of these sessions. And yeah, every month we'll spend an hour talking around various issues, and it'll be a good opportunity for staff and colleagues to understand all of those issues and what's going on and what isn't, and what the challenges are at kind of macro level. So today we are very, very lucky and fortunate to have two organisations work with us or give us some a talk. We're going to be discussing the subject of embodied carbon. For those who don't know or unsure, embodied carbon is in the building life cycle. Embodied carbon is the carbon dioxide equivalent, CO2 equivalent, or greenhouse gas emissions associated with the non-operational phase of a project. This includes emissions which are caused by extraction, manufacture, transportation, assembly, maintenance, replacement, deconstruction, disposal, and end of life aspects of the materials and systems that make up a building. So that's a bit of an understanding of what embodied carbon is. As I said, today we're going to spend some time looking at that particular subject. We've got two organisations that have quite kindly given their time to talk around this subject. One is an organisation called LETI, which stands for the London Energy Transformation Initiative. This is a network of over 1,000 built environment professionals that are working together to put London on the path to zero carbon future. They're a voluntary group made up of developers, engineers, housing associations, architects, planners, academics, sustainability professionals, contractors and facilities managers. Today we're lucky enough to have Duncan Cox, who's going to speak for us for about 15 to 20 minutes. And then alongside that, we've got, we're also lucky enough to have ECD Architects as well. They're going to be providing a bit more of a talk and a bit of a case study, which is relevant to Lancaster West. ECD, who some of you may know or may not know, are an award-winning architectural practice specialising in the design of low energy, low environmental impact buildings, cost effectively and to the highest of quality standards. Currently, they're working as part of the design team for the Lancaster West refurbishment programme, and we are lucky to have them in the room and on the team. And they've recently worked on one of our low carbon energy properties, 50 Verity Close, which you may or may not have heard of. So, so that's a bit of an introduction to the session and to LETI and ECD. I'll hand over now to Duncan, I think it is, from LETI, who's going to give us a bit more of a detailed understanding of embodied carbon. So Duncan, over to you.
Thanks very much. Can I share my screen?
Yeah.
Sorry.
Yeah.
Let me just. Got just display. So you should. Can you see that? It's just.
Yeah, that's fine.
Yeah. Yes. Okay. yeah, so I can skip through some of my slides because you did such a good introduction. But my name's Duncan Cox. I work in my day job. I work for a company called Thornton Tomasetti, where I'm a senior associate there. But I also am quite active in the LETI group. So as was described, it's the London Energy Transformation Initiative. And I wanted to just have a talk to you today about probably I'll frame it around a couple of guides that we produced, the Climate Emergency Design Guide and the Embodied Carbon Primer. My main focus will be around the Embodied Carbon Primer. So yeah, so LETI as a group is made up of it's a really powerful group in the fact that everybody there is a volunteer. There aren't driven by their company or competitive agendas. We've all got one common sort of ambition to reduce the impact, negative environmental impacts from in the built environment, and to do that is to sort of plot for a net zero carbon future. We are made up of such a diverse mix of architects, engineers, planners, clients, contractors, and different experiences, different abilities, and we all come together to, or not abilities, that's a bit harsh, different skills, that would be better. So, and we all come together to produce like these, each sort of year we produce we have like targets for our year that we want to sort of have some ambitions to tackle. It's been going since 2017, and it's sort of evolved into something that's really quite it's got a good sort of reputation, particularly in London where I'm based. We get invited to comment on a lot of sort of consultation, like planning consultation and advisory boards, and just as a group we do have a voice, and we're also, as well as the sort of technical side, it's sort of an activist side as well, so it's sort of got those sort of two ambitions. So as said, the primary aim was to try and deliver, thinking about how we get to this 2030 zero carbon ambition in London, and what we need to do year on year to get there, and it's sort of very sort of idealistic 10% by X date, etc. And you sort of see these sort of targets sort of appear from not just LETI but lots of institutions, and boards are sort of going, you need to be at this level by so and so. But we wanted to put a bit more to that in a way. So as we've sort of thought about how do we get there, this is the framework. How do we actually achieve that? And so what we started to do was started to deliver some different sort of easily digestible information. So stuff that wasn't overwhelming, and it wasn't just a massive code of how instructions, but sort of targets and guides that could be easily digested by throughout the industry. So this was in 2019. Now, sort of lost a year, and as everybody has, of when this was released. At the end of 2019, we produced the group produced this one pager, this net zero operational carbon pager. One pager with defined the most critical thing here, I feel, was the energy use intensity targets on the top left here, the low energy use, and what the targets should be for in terms of the operational targets for different sort of archetypes, and sort of just a high level sort of this is what we need to be doing if we are to deliver this net zero carbon, operational carbon. And obviously in that category was embodied carbon as well, which sort of sits within it, but I'll discuss that a bit more. And that one pager led to a release of this. We recognised that we needed more than just a one pager. We needed an actual design guide that designers could have on their desk and look, and sort of sort of rules of thumbs and how they should approach designing for this net zero future, rather than just this is what you need to do. This is a bit more, this is how you could possibly do it from experience gained from within our group. And it was written by over 100 volunteers. I am on there somewhere. And I forgot an important group that I didn't mention. We have a big sort of academic group involved, all different institutions and universities that not only participate in the conversations, but peer review what we're producing as well. So it's sort of quite a thorough sort of group that's participated in this. And within that design guide, we recognised that there were 5 key areas that we needed to help designers to deliver this net zero future: operational energy, future of heat, demand response, and data disclosure, and finally embodied carbon. And we were tasked with, I was in the embodied carbon sort of work stream, so we were tasked with writing a guide that was 10 pages long. And the more we started, because embodied carbon is a bit sort of it's not new, but it's sort of been a newer idea talked about in the industry. We ended up writing about 160 pages, so we released our own embodied carbon primer. That's why there's a separate 2 guides. There's a climate design guide and an embodied carbon primer. Within, I just quickly mentioned, within the design guide, these are really useful slides that we produce, which are the targets and the wall sort of U values and all the different sort of approach to hitting these EUR targets for the operational. But I just thought I'd mention those quickly. They're really useful slides to have a look through of where you might need to be, where we think you need to be. Within that, there's also the embodied carbon sort of targets in as well. So yeah, the embodied carbon primer was a standalone guide supplementary guide to the design guide that was really aimed at demystifying embodied carbon. I think it's there was a lot of, it shouldn't be it's not a difficult subject to get your head around. It's not that complicated. But it's also not as simple as some people want it to be. Some people just want it, right, we've tackled embodied carbon, done, let's move on. And when we think of it, so quickly thinking about like the carbon flows within our building, we try and think about a building as like having a whole life carbon budget, and you have your operational carbon and also your embodied carbon. So and we also introduced, like I'm sure you'll see, what the next iteration is having a bit more focus on circular economy that I can quickly talk about at the end, if I don't run out of time. Just checking time. So as was mentioned at the start, how we think about the energy flows and the associated emissions from those energy flows in a whole building. We think about the whole life carbon of that building, and this is essentially a life cycle assessment. And so you, at each stage of a building, from the upfront material extraction, so your raw material digging out of the ground, there is an associated energy flow to that, and often there will be carbon emitted in that process. And so your life cycle of your building will have all these different stages, which you may start to hear people talking about. Your A stage is your sort of raw material extraction, then your transportation of those materials to the sort of the manufacturing and fabrication, so your factory, and then so that would be your emissions associated to that transportation, and then the actual emissions associated to putting those materials together, whether they're like precast planks or I don't know, some air handling unit. So the energy at that stage. So that's what we would very much think about as cradle to gate. This is the emissions from the actual putting a product together. Then you would have emissions associated to the transportation of those materials to your site, and then your final sort of A life cycle stage would be your construction and installation of those elements into a building. I really need to hurry up a bit. And those would be your cradle to sort of practical completion. Your building's complete. But we don't stop there with emissions in our building. We then have, as well as the ones we're familiar with, we have like your operational energy. You're turning on your lights and off and heating the building, and your operational water. There's carbon emissions associated to that. But you also have these refurbishment and maintenance and use emissions. So if your choice of a material, you may need to replace it on a 20-year sort of program. So then that would be a replacement emission, or maybe it's a maintenance of that material. So there's emissions of that, and then there's finally there's also your deconstruction, what it takes to pull that building down, and that would be your C, and that's your cradle to grave. There's another life cycle stage, which is D, which is your reuse, recovery, recycling potential. This would become your sort of circular economy. So your cradle to cradle, how you can plan to reuse elements you're building today to be reused later in the future. What's their reuse potential? And there's all sort of strategies you can implement to sort of ensure that you deliver on that. I just wanted to show you may see a very similar process, and this comes from the sort of standard of how these are written in those A stages. So you may start to see sort of these tables pop up in reports, and that's all those life cycle stages are. So the ones, anything, so the B6, B7 are what we think of operational carbon. All the other stages are what we would consider as embodied carbon. So how we look at where those, again, going back to thinking about those different life cycle stages, if you have typically at that upfront practical completion, you will have a big embodied carbon footprint of the building. And then year on year, you will have carbon emissions associated to different stages. So you'll have your ongoing operational carbon, and this may fluctuate and hopefully goes down to zero as we decarbonise the grid, but perhaps I'm an optimist. But also at these periodic stages, you will have sort of the replacement stages. So uplifting embodied carbon at, say here, 15, 25 and 50 years when they're replacing maybe the glazing or shading, or there's a refit out. And then you have your end of life. So your deconstruction of those materials, building. And so you have to sort of look at where all these sort of flows of carbon are and carbon is and balance them out. And it's really important to sometimes think about how these can impact each other, how you're maybe putting in a high upfront carbon because you're defining a certain glazing arrangement. Maybe it's triple glazed units, but the impact on your operational carbon can be significantly reduced. So you start to think about the balances of these and whether you're having a very, very high upfront carbon for a material choice, but that's got high durability and replacement period of 50 years rather than 20 years. So you start to think about in terms of how does this look not just today when I deliver, but over the life cycle of that building. And what we find as we plot towards this sort of this 2030 target is that we've been focusing very much on operational carbon over 20, 30 years now. It's been on the sort of I mean, not massive, like not that hard in all those years, but there has been an awareness to reduce the operational carbon. There's been regulation and like Part L and stuff. So you are having these periods of reduction, and so we have a good trajectory of reduction for the operational carbon, and the embodied carbon is a bit lagging. And what we're finding as we move in these next 10 years, that the breakdown, typically we would see like the operational carbon takes up 60% of our overall, 70% of our overall carbon budget of the building. As we move towards this zero future, the operational carbon, the embodied carbon becomes more significant. And so we need to focus on some of this a little bit more and one of LETI's goals is to try and push regulation so that we get targets for these. What you do find is some of the ultra low operational carbon approaches can in fact lift our embodied carbon. So if we think of a passive house, which is excellent in terms of reducing operational carbon, that can give us a little bit of a lift in terms of the tightness of that facade and the insulation of it, and the amount of carbon that's gone into those materials. I'm not saying passive house is a bad thing, I'm just saying it can give us a little bit of a lift. But we've been thinking about how we need to approach at different stages what this sort of what the picture looks like in the next 10 years is quite important. So what we've set in the primary is targets of carbon targets, embodied carbon targets for different archetypes. I think at the present we have residential, commercial and school, and what they should be in. Well, this was written in 2019, even though we released it in 2020. This is good practice 2020. And then what it would be in 2030, 300 kilograms per meter squared, and then going towards a net zero target of 0, which I think that's highly ambitious, but you have to put it on there. But so we have sort of formed these targets for people to get an idea, but you have to be careful about targets. I always say don't get too stuck on them. The more we can engage people to start making reductions, that's the battle we're trying to do, rather than trying to hit these accurate targets. And they are being updated all the time. This is more about engaging you guys as designers and specifiers, etc., to start thinking about embodied carbon reductions. That breakdown again, as I was saying, as we look at as we move from the building reg compliant building, we have, like in this medium scale residential building here, we have like 67% of that carbon footprint associated to the operational carbon, 20% in the embodied carbon, and then 10% ish on the replacement in use stages. As that profile moves into a low energy building future, embodied carbon makes up over 50% of that carbon footprint, and the maintenance period, maintenance carbon is increased again. The percentage breakdown is high. So when you look at these different buildings, and I'll show you on the next slide. Actually, I'll jump to that quickly. So what we typically see in a building is, and these are roughly standard sort of numbers that we do see, that 50 to 70% is largely made up of the structure we find on most buildings. The MEP is a bit of a untapped beast in a way that the numbers are slightly, that we don't always have great accuracy on these numbers, but we tend to know that we're going to have 50 to 70% would be in the structure. The facade can go very much higher when you have sort of high performance facades. But when we look back at what that means, I don't know who's on the call, but if we're saying that 50% would be of this embodied carbon in the future is based around the structure, then the other half of that embodied carbon is going to be around the architecture and your services. And if you think about those, and those are the items that you would replace. So those are the items that also have an impact on this maintenance period. So that thinking about the future choice of those materials and how they are replaced becomes even more important as we move to these low energy buildings. Just wanted to point something out, because for a long time in a lot of these rating systems, and I'll stop soon, that there was a big focus on sourcing of materials, where we get these materials from. Don't transport them too far, etc. That's where you're emitting carbon for your diesel, etc., and greenhouse gases that way. But the transportation impact from our material choices is so small compared to the other sort of other metrics. So if your choice is between, say, here's a silly argument, say you were going to go for a CLT deck, but you had to source that in Austria, but you could get your precast planks in Northern Ireland, which is a lot closer. The savings you could make by the material choice of CLT totally outstrips that transportation uplift. In that, not all that. I don't want that to be the one thing you take and that's the choice, but you need to think about the material choice rather than the transportation choice. That's where you can have your biggest impact. I've done myself some studies further drilling down on where these impacts are, like where the different element, like big lifts in embodied carbon are, particularly in the superstructure, because that's largely what my company is. We're structural engineers and facade engineers, and you start to see that there's the biggest impact you can make is on your slab choice. Your floor, that takes up sort of 50% of the superstructure impact comes from your floors. Not always the case. If you have a high rise, then it goes into the walls a bit more. But so rather than focusing, right, let's reduce the carbon, let's think about the material on the columns or putting all like glulam, that wouldn't give you the biggest impact. So you really need to think about where to target those reductions. Within the primer, we do have some really useful information for designers, and this was like trying to, like, we're not telling you how to do it. Well, we're trying to guide you, like how you can make an impact at the different RIBA stages, who you should be talking to, who you should be engaging, what you should be doing in terms of your sort of embodied carbon checks, and whether, if you engage with a LCA specialist, what they should be doing as well. We also talk in the guide about how to measure, because if you talk to an LCA specialist, they will maybe try and bamboozle you with all these sort of terminology. You can make some really good upfront takeoffs from just looking at your material volumes and using some industry average carbon metrics for different materials. It won't be completely accurate, but it will give you a sense, and it's that sort of sense check and that narrative you can build into your designs of, I started to think about this, and then you can, as you move through the project, you can assess the accuracy. But at that, you can do these takeoffs yourself quite easily without having to do the full LCA, which was really impactful to do one. But I'm just saying it shouldn't be something that you don't feel confident you can do yourselves, but that guide how to do that is in there as well. We also got rules of thumb, so we sort of how you can reduce impact on the site, and then I think we got different materials like aluminium, concrete, steel, and there's some case studies in there and things you can consider and sort of further reading as well. So it's just trying to give you a steer of where to go. Our next steps over this year, as mentioned, we're trying to influence policy, and we're putting a big focus on procurement, ensuring what we design is delivered. And we've also introduced LETI Pioneer projects, which we encourage. If you have projects that you think are hitting some of these targets, we'd love to talk to you and love to showcase them if possible, and how you're doing it, and help others to learn from how you've approached it. And we have a whole load of work streams. These are not closed shops. We welcome anybody to get involved. It's like it's try and make it least ego-driven thing ever. So it's just people coming together to try and impact change. There's all sorts of work streams, retrofit part L. I'm obviously in the embodied carbon work stream, and my focus this year is on specification and procurement. One of the comments we got from the primer last year was that, and I made the same comment, that we're a bit light on ensuring telling designers how to specify and ensuring that it is actually procured. The worst thing we want to do is make all these lovely LCA analysis and then actually just doesn't actually get delivered on site. So we've been talking to lots of suppliers, contractors, manufacturers, and over the last 6 months to try and bridge that gap and work out what the barriers are to low carbon specification and procurement. Other work streams are further in the targets and circular economy, and a whole piece on further case studies. But like I said, we're open. Like, people could, if they want to take part, then just get in touch. There's lots of different activities. It can be, even if you're not an expert, you can just come and learn a bit and help out with some of the graphics if that's your skill, sort of thing. And that was me really, which is probably a little bit over, but.
Thank you, Duncan. Thanks very much for your time there and your presentation. Really, really good. Excellent kind of understanding what embodied carbon is and also the work that LETI are doing. I think Lizzie, you're up now to give us a case study of how that's been implemented on Lanc West.
Absolutely. Sorry, one moment. Right, full screen. So as Sean said, ECD worked on the retrofit of 50 Verity Close, and we've carried out an embodied carbon assessment of the work that we did there and of the existing building. It's far from perfect, it's fairly high level, but we found it quite useful for assessing what we've done ourselves, but also looking at how we might carry on our work around the rest of the estate and inform the decisions we're making about materials for the retrofit of the wider estate. So now story time. We're going to have a history and a future of 50 Verity Close in carbon. This is partially fictionalized and with some very dodgy photoshopping at times. So way back in the dim and distant past of 1969, Verity Close didn't exist at all. You can see on the left there the Methodist church, which still sits opposite Verity Close, but there was some housing and a pub just on the corner there. But in 1979, it was decided to change all that and build Verity Close. And we can see here the plan of the whole close, and in green highlighted number 50 Verity Close. Now, I can't verify whether the builders of Verity Close did in fact wear patterned shirts and keep their shirts unbuttoned halfway down the chest, but we know that they did build some large concrete foundations and brick walls. Well, they were brick and blockwork walls, timber roof with concrete tiles on, and all of those materials took energy to get them out of the ground, to bake the bricks, to bring them to site, to put them together on site. Making the concrete would have been an energy intensive process, and a bit like these guys here are doing, there would have been some metal reinforcement in that concrete probably. So all of those things took energy, and we've worked out that roughly combined all of that energy that was used would have emitted about 50 tons of carbon. So we start off at the end of the building in 1979, 50 tons of carbon has already been emitted to make that building. However, this family move into this new home and they're really grateful for it. Let's call them Michael and Sally with their 3 kids, Jane, Catherine and Tom. So they move into their new home and it's nice and warm and it's bigger than their old house and they're very pleased with it. And it's got a gas heater in each room, and so they burn gas to warm their home, and burning that gas emits about 10 or uses about 10 tons of carbon every year just to keep their home warm. So you can see that on the graph over here. We've got our yellow 10 tons of operational carbon, which by the way is just space heating, not all the lights and everything, and about our 50 tons of embodied carbon from building the building in the first place. Now, skip on 10 years, it's about 1989 now. Fashions have changed a bit, cars have upgraded and photography is in colour. And each year on the graph here, you can see that every year from 1979 to 1989, about 10 tons of carbon have been emitted in keeping this building warm. And we can see on the bottom graph here that we started off with our 50 or so tons of embodied carbon of the material, and every year we add another 10 tons, and that pushes up our overall whole life carbon emissions for the building. So by 1989, we're already at about 160 tons. Now moving further on, we get to 1995, and this is a bit of a guesstimate, but we know that at some point in the history of the building, some insulation was put into the cavity of the existing walls, and probably some loft insulation was added. So we can see on the graph here that we've got an extra bit of embodied carbon in pink, but our operational carbon emissions have just carried on as they used to be, 10 tons a year. And we can see on our lower graph that that's carrying on adding more and more whole life carbon emissions every year, upwards and upwards. So if we take, for example, about 2004, you can see that we installed our new insulation back in, when were we, 1995, we installed our insulation. And now that meant that the amount of energy and therefore carbon that we're using every year has dropped because the building is better insulated, and so it loses heat less quickly. So you don't need as much energy to heat the home. So operational carbon every year has gone down. And you can see on our lower graph that it was going up pretty quickly before, and now it's not going up quite as quickly anymore at the end here. Now we know that in 2013, some new double glazed UPVC windows were installed in 50 Verity Close. We can see some guys here installing those windows. And after they put them in, the house looked a bit like this with its new windows. And again, that took a bit more embodied carbon to put those windows in. But it did mean that the home again got a bit warmer inside and used less energy to heat it. So now much closer to the present, in 2020, it was decided that the house was going to be retrofitted, and ECD were involved in the design of parts of this process. And we can see here that as they started to take the building back to its structure in order to carry out the retrofit work, you can see all the history of the different people who lived here. So we had that first family that moved in, Michael and Sally and their 3 kids. And no doubt other people lived in the home since. We don't know who they all are, but they had different colours of paint and different wallpapers. We can see where their cupboards have been removed from the wall. You can see some pipe work from the old gas boiler, the gas heaters in each room. And we can see as well that a lot of material had to be stripped out of the house. So all this wiring and so on that was there all got taken away. And hopefully some of it got recycled. But there's a lot of energy that was already, energy and embodied carbon that was already in those materials. And that's been taken out of the building. But in order to make the building really low energy building in the future, we put in a lot of new stuff. So on the top left here, we've got our internal wall insulation that was added. It's part way through it being installed. It doesn't look like that anymore. We've got a new hot water tank and pipe work. We've got a new air source heat pump. And we've got these new triple glazed windows. Now they're pretty chunky to look at, and the embodied carbon of those windows is quite high, but they're really good for keeping the heat in. So they should help us to reduce the operational carbon of the building into the future. But what all this means is that we added about 30 tons of embodied carbon into the building just in our retrofit work. So that really looks like quite a lot of energy, quite a lot of carbon that we've emitted in doing the work that we've done. So it just highlights how important it is to make decisions about the embodied carbon of the materials we're using. But the good thing is, as we look into the future here, towards say 2051, our operational carbon has gone really low. We're now down to about 0.5 ton of carbon dioxide every year, just to keep the building warm, which is so much less than before. So yes, we put in this extra embodied carbon in doing the retrofit work, but what it means is that we'll be producing far less operational carbon emissions into the future. And maybe in about 2051, we might need to replace, maybe a new family will move in, we might replace the kitchen again. Some of the services or the windows might need replacing. But what that really highlights is how important it is to maintain what we've just put into the building. So changing the filter in the MVHR unit, for example, will help keep that unit in the ductwork clean so that it's functioning efficiently and it doesn't need replacing so often. And if there are problems with the windows, we should first look at maintaining those windows rather than just replacing them. And that way they can have a longer life and we won't need to replace them so often. So we won't be putting so much more embodied carbon into the house. But say in about 2051, so about 30 years from now, maybe the windows are going to need replacing. And as I say, perhaps a new kitchen. So we'll have some extra embodied carbon going in at that point. But you can also see on this whole life carbon emissions below that at the beginning, up until the retrofit, they were climbing really steeply every year as we used sort of 6 to 10 tons of carbon were emitted every year just in keeping the building warm. But from the time that we did the retrofit, i.e. about now, looking forward, that comes much flatter. We're not adding nearly as much extra carbon every year just to keep the building warm. And we jump on to 2081, 60 years from now, which is a typical time period for assessing whole life carbon. And I don't know whether there's actually going to be people on hoverboards or robot dogs or anything else. But as I say, you can see that this trajectory for the whole life carbon has really dropped off and flattened. We flattened the curve, which everybody knows is a wonderful thing. If we hadn't carried out the retrofit now, this line would have carried on up and up and up and up, and we might have got to, say, at least 1,000 tonnes of carbon emitted by the building. So kind of looking at that all together, we've got a nice finished house here, just back to today now. And over the period from 1979 to our imagined 2081 scenario, the building's operational carbon might be around 385 tonnes, with 96 tonnes of embodied carbon having gone in both at the beginning and in the retrofit work and in the maintenance that we've done over time. But if we look just at the period from now until 2081, that's a really tiny proportion of the overall operational carbon, so that's gone down enormously. And our embodied carbon, both from the retrofit and maintenance from here on, is fairly low, but it's actually more than the operational carbon that we're producing in that time period, because we've managed to make the building so efficient that it's not needing so much energy to keep it warm over time. And it kind of highlights how important it is that from here on out, we really look after the things we put into the building so that we don't have to replace them too often, because that embodied carbon part has become really important. I'm now going to hand over to Niall, who's going to talk to you a bit about the specific materials that we have put into this retrofit and how they affect that overall embodied carbon.
Hi, thanks, Lizzie. Lovely story. So basically, taken from those learnings, the key outcome from what Lizzie was saying and what we can see and what Duncan reiterated is we see that as the energy use significantly drops due to the retrofit and the operational carbon drops off, you actually start to see a spike in embodied carbon due to some of the potentially high intensity carbon materials that are inputted. And if we take this example where we looked at the retrofit of 50 Verity Close, what this analysis diagram here of the colouredy diagram in the bottom corner, you can see they're representative of proportions of the contributing the highest proportions of embodied carbon per material when we chose those materials for the retrofit. In approaching 50 Verity Close, we were working within a series of constraints around space constraints and in around combustibility issues. So let's say the palette of materials was rather limited due to those factors. So we did as best we could. But as you see from this diagram, we can do a lot better. And you'll see the largest impact that you see here in the green is actually the finishes and the fittings. So like the kitchens and the bathrooms. And if you think of the materials in kitchens, generally off the shelf kitchens are plastic-based laminates bonded over chipboard materials, not the best materials around in terms of carbon. And these are some of the areas where we've now identified and have known from experience that are kind of key targets where you could actually reconsider what those kitchens are made of. Then yet again into the bathroom, plastics and so on. So what could you do differently? And surprisingly enough, one of the very large contributors here is finishes like carpets. What are most lower grade carpets is polyester based. So yet again, a plastic based product. And then looking at paints, should you consider less petrochemical based paints and so on to really bring down that green element there. And then looking at, even though we chose for the primary element that reduced operational carbon was a low carbon diatomite, like essentially render insulation internally, the impact is relatively high. But look at the the very bottom there, the light yellow kind of color, the aerogel, which is really thin plastic based insulation, and that's only on the floor and a relatively small area comparative to the walls. And you can see proportionally, even though the wall is a bigger area, the floor is a much less area, because the floor is a higher carbon aerogel material, that the impact is still relatively high. But I won't go through the rest of them, but you can basically see you can identify pretty quickly there where the big impacts are. And the key outcome of this is going forward in the remainder of the refurbishment of the estate is actually we can learn from this. And this is an iterative process, and every time we do something, we learn from it and we take where we can save. Go on to the next slide there. So essentially, this is breaking that diagram down into like a pie chart, and you can see when we look at retrofit already by default, if you look at the existing side in the about 2/3 of the diagram there in white is the existing. So like the big contributors are, especially in this case where it's concrete and brick, that carbon is already, you know, embedded in the building. And if we by retaining that, not by demolishing and rebuilding, that is essentially a carbon saving go forward. And that's evidence in the diagrams that Lizzie's shown earlier. If you look at the light blue, if we're looking at the retrofitter, we can still see there's about 1/3 left of carbon that we can potentially make even further savings and drop, either create a balance or drop the embodied carbon even below the operational carbon, and really move towards, you know, low or zero carbon, truly zero carbon buildings. And some of the actions, kind of primary actions you could do here is choosing low carbon products from the outset, from responsible, local, if possible, sources. Choosing, as Duncan pointed out earlier on, durable products. So if you want to choose brick, which is already the case in here, say in a new build, choose brick, or for this retrofit, if you wanted to choose a high embodied carbon windows, for example, ensure that they're durable so they last time, so you don't have to replace them in, say, if you repair them and maintain them possibly in 60 years time. So I mean, durability is a key factor here, but it is about quality, and perhaps there's a balance there between cost and so on. And yet again, to reiterate, is proactively maintaining fittings and fixings, and in that choosing easily maintainable and repairable products. Find products where the manufacturer can provide you with parts and that they are accessible. So designing for serviceability and demountability, allowing that access to make those repairs either on products, components, or service and method components. And then designing for flexibility. So actually future-proofing in terms of both the services and be able to clean them and so on, but also the spaces, and allow flexibility within the housing unit itself. And then, you know, you can go right down to actually choosing products that have a take back or a leasing system where the actual supplier will take back or recover the material at the end of its useful life and roll it back into their production process in a closed loop so that no waste is created, or zero waste, limited waste created. And then ultimately, like, designing for disassembly. So if you have to repair a window, can you take that glass out? Can you take elements apart? And so on. And this all goes into the whole life cycle of the building. And ultimately here, the whole aim of the game here is reducing waste, and therefore reducing any additional carbon that may be needed. And waste is equated to value and cost. And it is about the site, it is about the building, the life of the building. You can see that people live there, the building goes through a life and potentially forever. Go on to on the last slide. And so just putting this in the context of the diagrams that we've seen and over the whole life of the building. If you look at the very top right-hand corner, there's a kind of a house motif. And if you look at all those cycles, as you go to the center, they're the shortest life cycles. And think about this as a house. What do you change most frequently? Your carpets, or you paint the walls, and that, if the smallest circle is representative of what changes most quickly. So if you can say, okay, if the paint changes every 5 years, if someone else moves in and the furniture changes, you know, you can really make a significant contribution to reducing carbon in those very short cycles of materials. And then going out in that diagram, you come to space and moving partitions around and design around flexibility and so on. You can control the amount of carbon in there. And then it goes all the way out into the very long life cycles into structure. So if you can retain structure, you know, retrofit first and so on. And what this starts to go into in the realms of what we call a circular economy. And the whole purpose of that, or the whole driver behind that, is the idea of keeping products, components, and materials at their highest utility and value for as long as possible, and they're repaired, reused, recycled, minimizing waste throughout the life of the built asset. And this comes through actively maintaining, monitoring, choosing appropriate products for in kind of life cycle thinking, and also what's very useful here is the idea of recording and tracking the asset throughout its life. And potential ways of doing that is actually looking at trying to get insight into your building through smart controls and monitoring occupant feedback on repairs or performance of the environment, whether it's to do with operational carbon or not within the building, but also using through BIM-based platforms and digital platforms through which we've discussed with some of your colleagues and are acting on the rest of the estate through material passports and trying to create this digital or not kind of environment where you can actually tell the story about your building and provide the relevant and correct information for your team going out to site to repair and maintain the building, that they know what they're looking at, they know exactly what the material is, and if a product reaches the end of its useful life, that you can say, I know exactly what's in this product, and I know that stream of where that can be recovered. Say I know it's made of X, X, and X, and I can recover that in a safe, healthy environment going forward. And I hope I didn't overload you there, but that's from me. That's enough for me.
Brilliant. Thanks, Noel. That was really, really good. Excellent presentation from both Lizzie and Noel. I've learned an awful lot there. I'm just seeing in the chat, well, there doesn't seem to be many questions in the chat, but I'm just going to open up the floor now to anyone that's got any questions or stuff they want to ask Duncan or Lizzie or Noel. I know we've got about 8 or 9 minutes left, so feel free to chip in now if anyone's got any questions that they want to pose.
Could I ask a quick question, Sean?
Yep.
The panelists, would you recommend a particular carbon standard? Because we all know there's different sources for describing how much carbon is in a particular product, and that's constantly changing because the way you make materials, the amount of carbon and energy that makes materials or helps transport goods changes all the time. So, Lizzie, maybe what do you guys use as a sort of go-to for checking the carbon in materials? I know it will depend very much on the specific product, but generically, concrete, window, door, where do you normally take your sources from?
In the analysis that we did of 50 Verity Close, we used a bit of a combination, which is always a bit dangerous, but we used Hawkins Brown Architects have made this great tool called HBERT, which allows you to use your Revit model, and it has materials that tell you already how much embodied carbon they have. So we used some of that, and we made our own materials in that using environmental product declarations from manufacturers where we could get hold of them. But I had to sort of fake it with some of the materials because I couldn't get the specific product, but I took one as close as I could to the material that we used and used that. And then for the services and the fittings, which we didn't do the spec for the fit out, so I don't know exactly what went in there. Or indeed we didn't spec the services ourselves either. We basically took the assumptions that are in the LETI embodied carbon primer about the proportions that we might likely have for those. So it's a bit of a mishmash, which is a bit dangerous, but on the other hand, I think it still enables us to talk about both the trajectory of the whole life carbon and the materials that really matter.
Yeah, we do a similar thing. Sorry, I think we do a similar thing.
All of that, Sean, is based on the IC database.
Well, some of it is, but the EPDs aren't.
Yeah.
Yeah, I mean, we do a very similar thing, but what we generally try and do is boil it down to some quite binary choices, because I think, as Duncan was saying, it's trying to make a strategic decision. Are you heading the right direction, the wrong direction? I don't think we can ever really truly believe the carbon figures we end up with, but it might help make a choice between one thing and another. So we just literally measure our foundations and compare two foundation systems, one to the other, to make a decision, rather than using something like a generic carbon load for raft as opposed to piled foundations, because it's just not detailed enough. So yeah, thanks for that.
Duncan, I think there was a question in the chat from Robert right at the very start. How does someone join LETI? What's the process that you go through to joining? And can anyone join? I think you're on mute.
Yeah, sorry. Yeah. Yeah, I did write on there. Anybody can join. It's like there's no anybody can join the mailing list. There's if you go, I sent links to the mailing list and it asks you if there's anything you're particularly interested in. If you check on the website as well, there's the 2020 workstreams so you can have a look and see if any of those interest you. But even if it's like, okay, I don't know, they interest me, but like I said, my expertise is actually in technical writing or something like that, rather than put that down, because it's we need all sorts of skills. So it can be you don't need to be an expert. Don't feel you need to be an expert in embodied carbon or operational carbon or circular economy to join. It's we're certainly certainly not all experts in everything. So it's more the merrier, and I think I've gained so much from it just being around. Like I say, I work for structural and facade engineers. Just being around for me, being around the services and the architectural professions and listening to their considerations is really interesting and valuable when we consider how we can all work together to make those reductions and what their drivers are, because the professions are all slightly different. I hope you sort of got that from looking at the life cycles of where the biggest impact. I think the presentation by Lizzie and Niall was excellent, just to demonstrate how their thinking is like on more the architectural products, and it's so critical how they think about those life cycle, those materials. Sorry, I went off on the tangent. Anybody can join.
Also, in terms of joining LETI, my understanding is that particularly, most of you guys at RBKC and that clients and local authorities, your knowledge and expertise is particularly welcome, because
Definitely,
it's easy to get excited architects on board, but it's harder to get people from local authorities. And without your input and you guys procuring in certain ways and understanding the stuff and giving us your insight, we're never going to be able to make all of these changes that need to happen.
Yeah, any procurement experts, please join. Because we're scrabbling around.
Because also,
trying to present what we know what we've got.
I was in the hydrogen work stream and I didn't know anything about hydrogen when I started, and now I know a lot more. But also sometimes it's useful to have that person who doesn't know, because they can read it and go, would someone who doesn't know understand this? And that's a really useful skill as well. So sometimes being the useful idiot is helpful.
Definitely.
Sean, you're on mute.
Sorry, guys. I was just going to ask, is there any other questions that others have? I think Sharon just put something in. I'd be interested in the types of questions we should be asking of our material suppliers for internal fit outs to drive the right results. I think that was from Sharon, and then I think Rebecca from our comms teams. LWE residents can stay up to date with the carbon neutral refurbishment. But that's a bit of a plug for our of our newsletter. Yeah, that question by Sharon is an interesting one. I don't know if any of you want to answer that or can answer that.
Yeah, I can say. Go ahead.
No, you go.
Go on now.
When you're talking to suppliers, I mean, as the client and as the designers, we have to push the suppliers to be doing the right thing, and just by asking the question. So what are your materials made of? Where are you sourcing those materials? You can talk to us about getting or Duncan about getting into the depth of measuring that carbon, but it's like I pointed out earlier, it's you did the more, let's say a good way of doing it, the more bio-based the material, the better it probably is in terms of embodied carbon. And that has other impacts in terms of when you're dealing with space constraints and combustibility. But generally, as a rule of thumb, you can think if you want a nice new kitchen for your fit out, what actually are those materials made of? And that's a good way of starting off. And it's not that complex, really. It's just, if it grows, it's probably pretty good. And it's at that kind of starting point.
Also, I think request environmental product declarations, because one, companies need to be providing them, otherwise none of us will really be able to assess those products, but also it pushes people to actually think about it. And it's been interesting as I was asking those questions for the analysis we just did. You know, some people, yes, they've got them, others they're working on it, and other people came back saying, what is that? Some surprising companies who I thought would know. But the more we ask, the more people will do it, and they realise it's something that people care about and might be making specifying decisions around.
And really importantly as well is actually asking about, you know, the durability of the component, but also can you actually get replacement parts? Because in the life of the building, which is far longer than the build period, you know, you want to be able to replace things rather than having to throw it in the bin every time. Like, so in a current situation, you might rip out the whole kitchen because you can't get the part. So that's a key driver, I think, going forward.
Just a question from Jeremy, just coming to the chat. Jeremy Plester, is there a standard system for environmental product declarations? Something we could ask for by name when procuring?
They should be third-party verified and type 3 EPDs. If you what you should remember about, just if I'm jumping in there, but if you're requesting an EPD and they supply one, it doesn't mean that material is the most environmentally friendly product out there. It just means they've had the assessment done. So it could be a crappy material, to be honest, but it's not often the case, because if they've gone to the bother of doing it, then they normally have quite a good. They're a bit more prouder of their product, but they're not all comparable. So you need to check they have the same life cycle stages, whether it's assessing A1, A3, or whether it's got the B's and C's in there. And also be careful how, if you're selecting timber products, how they quantify the carbon sequestration in their EPD and where that sits. It's most commonly shown in the A1, so that's how much carbon. So you'll see a negative value, and you can get in complications with that. So you just need to be aware of check where the carbon reporting for natural materials is. Yeah, you have to ensure it's got sustainable forestry or whatever it is that isn't necessarily sustainable. That material you can count the carbon sequestration. I've overcomplicated that.
Thanks, Duncan.
Sharon, we can definitely have a more detailed discussion about that if you like.
Yeah.
Do that. That sounds a better answer.
Guys, I'm just conscious of time. We've run over our hour, but that was a brilliant session. If there are any more questions for Duncan, Lizzie, and Niall, feel free to ping myself or Lizzie Lambrew an email, and we can forward them on and get an answer for you. I think if you guys are happy to, we'll be able to share the slides from today's sessions onto the people that have come to the session as well, and we've also recorded it as well, so there may be an opportunity for us to post this internally as well. So I'm going to wrap up for now, guys. I really appreciate your time, Niall, Duncan, and Lizzie. I think that was a fantastic session, and thanks very much. And next month we've got the Retrofit Academy coming to give us a talk on the purpose of retrofit and its importance within the context of the work we do. So thanks for today. See you next month. Take it easy, all guys. Cheers. Bye now. Bye.
Thank you.
Bye.
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 Thanks, everyone.